kids? We are going to do an orbit problem, which is just really circular motion with, some bigger numbers. But here's our problem. So we are going to say, all right, geosynchronous orbits are super important for things like GPS satellites and military satellites. So we're going to say, I have a satellite in geosynchronous orbit over the Earth, and we need to find the altitude of that satellite. We need to find the gravitational field strength where that satellite is, and we're going to figure out like how fast do I need to get that satellite moving, to get it up there. Okay, or not to get it up there, but once it's up there, what is the orbital speed? So that's what we're going to figure out. So, what should we do first, kids? Let me think about this. Oh, yes, you should draw a picture. So let's draw a picture. So here is the Earth, and here is our TIE fighter, satellite, okay? And our satellite is going to be going around in a circle. We're going to say it is a circular orbit. If it's geosynchronous, we know that the period is going to be 24 hours, okay? Which, if you do some math, so let's do some, math. So 24 times 60 times 60, so if we want seconds, because, again, if we're trying to find orbital speed, and if we're going to be using, big G, which we will be, big G is in terms of seconds, so we need to do that. We get our orbital period to be 86400 seconds, okay, because that's 24 hours. And then it's like, all right, so I kind of drew a picture. I need to know the altitude. I need to know this. I need to know the orbital speed. So what else do I need to do? Oh, let's draw an FBD. So if I draw an FBD, well, okay, the only force acting on my satellite is the force of gravity, because the force of gravity is what's causing my satellite not to move off in a straight line. It's pulling it in. So then what do I do next? Well, I'm going to write my equation from my picture. So, that means Fg equals ma, because, hey, that's my net force. But remember, it's a special net force, the centripetal net force. So that means this is going to be AC. And then I have to plug stuff in. Well, then it's like, I don't want to use just m times g, because I'm going to have to find what g is, as you're going to see. So I'm going to use my universal law for gravity. And then I'm going to plug in v squared over r for this. I can do a little bit of math. So that means little m goes away. Isn't it nice that we make it a big M and a little m? So big M is obviously the mass of the Earth. Little m is the mass of the satellite. And the mass of the satellite doesn't matter. So if I'm shooting a satellite up there, who cares? And then one of my r's will also go away. Now, if I want to know, if I know this is my period, it's like, wait a second, I have this equation. I don't see period in there. Do you? Well, we can put period in there, because if this is an object moving in a circle at a constant speed, we know that if it's moving at a constant speed, that v equals d over t, and the d around the circle is 2 pi r, and the time would be the period, so let's plug that in. So I'm going to get g m over r. Now remember, this is going to be important. That is your r for this equation. It's from the center to the center, which is not the altitude, okay? The altitude would be from the surface to there, okay, which we'll talk about later. But look, we got to keep that in mind. Equals 4 pi squared r squared over t squared. All right, let's do a little bit more algebra here. So I am going to say, all right, so because I'm looking for, let's just go in order. We'll find the altitude first. Well, if I need the altitude first, I first have to find r, and then I'm going to subtract the radius of the Earth from that. So let's do that first. So I'm going to solve this equation for r. So I'm going to come over here and do it. So I'm going to get r cubed is going to equal, we got to be able to do some algebra here, folks. So gmt squared, period squared, over 4 pi squared. Okay, so again, I just did some algebra. I'm really good at algebra, I know. So then we just got to plug our numbers in. So this is where I would recommend that you pause the video and you get out your calculator and practice it. I'm going to stop right here and then I'll do the math too. So, but you can pause it and do the math, and then we'll be back in a second. All right. Bye, kids.